Hi everyone, I am welcoming all one and all who have joined here to this session. And today we are starting with the Cloud Computing Foundation series. So this is basically today the session is about the basic fundamentals, how it's before cloud computing and after computing fundamentals. So I want to have a small introduction on AWS UG Women in Tech. So here, the AWS UG Women in Tech is the community where which is started with a vision to encourage more women to step into cloud technologies and share their learnings and grow together in the supportive community forum. So it is supported by AWS Developer Relations and uh, today this series is organized by AWS Women in Tech Chennai chapter, and as the name suggests, it's not only for women, so it's open to everyone to attend and learn from, but it organized by the women's from Chennai chapter. And several glimpses of our work. So we have organized almost 4 to 5 in-person events and two online events, and this series is going to be have till Feb. So this is a glimpse of our Architect Day 2025 and QCLI workshop and data and AI meetup, and we have organized 2024 Architect Day, and also we had a April month online meetup. So we almost organized like 5 to 6 in-person events with almost reached each session. Architect Day has reached 200 to 300 professionals. And if you want to deliver any online session or in-person session, so you can go and you can fill the CFP form over here. And also we have a meetup page for AWS Women in Tech, so you can join the Women in Tech meetup. So you can able to attend throughout India. So women in tech from different localities are organizing the event, so you can join and attend the session wherever you are from. And this series, we have a plan, so you can learn attend session, you can ask a question and grow your AWS fundamental skills. And if you want to give a talk, so from this session, if you want to give the talk, so here today you have a session and you are going to learn valuables from this session. And if you want to share your takeaways, and you can reach out to me, and you want to have a mini lightning talk on the next session next month. So it is possible to share your knowledge with the community piece. And you can also write the blogs and publish your learnings and tag us, and we will feature all the articles in our AWS Women in Tech page from this series. So it is organized by Sridevi, and who is an AWS data hero, and Ramya Nadesan, and myself, Abinaya and Vijay Lakshmi, Jeevita. So these are the AWS community builders from our Women in Tech Chennai chapter, and Komati, who is an core team member. And I would like to thank volunteers for this online series, Nandini and Rasika, to involve in this online series organizing part. So thanks everyone. So over to you, Pawan. Okay.
Thank you so much, Abby. I'm sure this will help all the interested people to join the community, especially they want to learn as well as share. So, with that, let's start. Come to the session now. Uh, Let me start sharing my screen. Once I do it, just confirm if you're able to see it. Are you able to see my screen now?
Yes, Pawan.
Hello, can you hear me?
Yes,
Yeah,
it
it is
is
visible.
visible.
Okay, thank you. So, as I defined cloud computing fundamental series. So, What we're going to cover in this session today, we'll be talking about cloud computing foundations, building blocks, I would say, and then we'll go on cloud storage and talk in detail about cloud storage in general, and then we'll deep dive on AWS cloud storage. However, it all depends on how much time we have. We also plan for hands-on. However, we are left with probably 50 minutes now, or even less than that. So depending upon that time available, probably we can have one more session if you are all interested to have hands-on on the storage part. So that's the agenda for today. So now let me ask you a question because we are talking about cloud computing. Do you any of you want to give it a try, especially the people who are excited about cloud or working on the cloud for a while? In one or two lines, if you have to define cloud, how do you define it? I'm not sure
Actually,
if
when
people.
I okay, so may I?
Yeah, yeah. Go ahead, please.
Yeah, please go ahead.
Uh, okay, actually, when I applied for a captainship that time, like I tried something different to define the cloud. I defined the cloud as a tiffin box, as our tiffin box as like 2 3 containers, and we store into it. So similarly, cloud also has some containers, and where we can do the storage.
Okay. Yeah, that's a I would say good way. However, yeah, it's quite simple way to explain it. Um, yeah. So let me define cloud in relatively simpler way, and it's a bit technical way to define it. So how or if somebody asks me what cloud is and what is the most important benefit of cloud, then I would say that cloud is uh, a virtualized network and data center. So if someone asks what is the benefit of cloud, I would say that the benefit it provides is the agility while providing the high availability and scalability. Now, when I mention agility is very important context here. It is the agility in which context uh, I would say on-premise will never be able to beat cloud because you can get you can spin up a virtual machine, for example, by click of a button. It is so fast, right? So it is an agility which makes cloud, I would say it's one of the main reason due to which organizations, especially startups and all, are going and adapting towards cloud, but they're moving away from on-premise. They're acquiring cloud computing. So they are migrating their workloads and moving towards cloud. So that's one of the reason. Agility is one of that reason due to which they move towards it. So I started in the beginning and said that it's a virtualized network and data center. So when I say data center, it incorporates almost all the components on-premise systems have, and network, of course, network is the important part of that foundation which data center uses. So these two are the most important component. However, the term which I used, virtualization, I believe that is one factor or that is one foundation which is the reason behind the inception of cloud. Uh, Even though virtualization was there since decade. However, cloud came quite later. But nowadays, all the public cloud provider, whether it's AWS, Microsoft Azure, Google Cloud, OCI, Oracle Cloud, IBM Cloud, you name it, each one of these cloud providers are providing majority of the services or public cloud provider services or managed services in a virtual form. You get storage in virtual form, you get network, firewall, everything is virtual. So virtualization is the reason behind cloud. So let me explain a little bit about virtualization. Are you able to see my screen still?
Yeah, it's
Hello.
visible, Pawan.
Okay. So virtualization is the creation of multiple virtual environments from a single machine. What we achieve by this is we make an efficient use of the resources of that single machine which we have at our disposal. What we are saying here is, we are having, let's say we're having one hardware, right? One one hardware, one machine, right? One computer. And that computer has everything. It has memory, it has a storage, it has a RAM, right? So how virtualization is possible is, there is a software called hypervisor which makes it possible. So using hypervisor, virtualization creates a layer of abstraction on the computer hardware and divides its resources, processor, memory, network, and storage, and divide into multiple virtual machines. However, every virtual machine has its own operating system, which gives us impression as if we are working on a separate physical computer, even though the underlying hardware is same. So that's virtualization. So the EC2 instances, have you heard, if you have heard of, right? So that EC2 instance you're working on, it's a virtual machine. It's a the actual machine is sitting somewhere in the data center of AWS, in a specific region, in a specific availability zone. Again, I do not want to make these terms in this beginning of our session. However, if some of you who have already worked on AWS have used EC2 instance, for example, then what I mean by virtualization is, the EC2 instance which you are getting, it's one virtual machine got created out of, and alongside that virtual machine, there must have been hundreds of virtual machine got created from a single physical machine, which is sitting in a data center of AWS, specific region and specific availability zone. So that's what I wanted to give an example of. Now, as we are talking about virtualization, I want to still highlight the containerization as well, because it's not same, it's different. However, it's related. So, what is containerization? And I'm very sure you must have heard of containerization nowadays each and every time, right? Kubernetes and all of the container Kubernetes and everything, right? So that's why I just wanted to touch upon as a foundation, so that you know about it going forward. So containerization is the process of packaging an application with all of its dependencies, such as libraries, binaries, config files, right, into a single isolated unit called container. This container runs consistently across different environment, such as developer's laptop. You can put on cloud server, because it shares the host operating system's kernel, but runs in its own isolated user space. So one important difference is between virtual machine and container is, uh, the container does not have operating system. So operating system itself, if you just see even virtual machines operating system, that takes good amount of space, storage, and other resources it consumes, right? Whereas and that makes virtual machine quite heavy, whereas container is quite lightweight, right? And also it can work, you can create container in your machine, and it can work seamlessly in your machine, on a virtual on a Windows, as well as on Linux machine, on cloud, everywhere. So it is compatible across platforms. So that's the difference between virtual machine and container, right? So there will be some topics which I might go a bit deep. However, some topics I'll just touch it upon, because we are having limited time, and the topics which we are going to cover, it's important that you understand that specific topic, because cloud in itself is a huge set of capabilities, and then different topics are there. So I do not want you to rush through, neither I want to rush through. I want to cover certain topic, and at least I want to ensure whatever topic and detail I am discussing with you, at least you become comfortable and you start developing some understanding. So that's the purpose of the session. Now, high availability, right? What is high availability? As the name suggests, right, the system should be highly available, right? So what are the features of high availability? If I have to ask someone, or if I ask someone, or if I have to explain to you, right? So I have listed on these three features. One is redundancy. So ability, what is redundancy? It's the ability of a system to maintain secondary servers that are copies or replicas of the primary server, and that can take over from the primary server. So I'm sure some of you would have worked in IT sector. Then you would have come across scenarios like one server goes down, And then if you're having other server which has been set up as either active active or active passive, then the second server, which is the secondary server, it takes over from the primary server because that server is not working. So that's the redundancy, because you're providing an option so that your system is up and running all the time. So redundancy is one of the important factor to ensure, which helps achieving high availability. Next is failover, the ability of a system to transfer all of the workload from a failed server to another server. The example which I gave about redundancy, like you are running an workload. Workload is nothing. Meaning of workload is you're running, let's say, an application, right? You have hosted one application on a server, right? Now you're having primary server to and secondary server, which are running, let's say, active and passive, right? Now, what is the meaning of failover is you're having certain configuration, and that configuration is getting kicked off the moment the server one is getting down, and it is ensuring that the second server is up at the same time. The workload, the application which is actually hosted on server one, but the configuration ensures that now it is running on server two, the secondary server. So that's the meaning of failover. It is not the second server getting up and started working. It is about end-to-end application started working now on the secondary server. That's the meaning of failover, that your workload started working on the secondary server, not on the server one earlier. Workload balancing. So this is another important factor to provide high availability. The ability of a system to automatically direct client requests to the server with the most workload capacity. So what is the meaning of this? The meaning of this is, let's say, you are having more than one server, as I mentioned, right? You are having two servers, let's say, right? Now, workload balancing is nothing. It's about having that internal mechanism through which it gauges that this particular server is getting overloaded now, right? You're having user interface, right? Let's say, for example, you're having uh, high request coming all of a sudden, right? So what will happen is, let's say your server can manage only 5,000 requests. Now you are getting, let's say, 8,000 requests. So the remaining 3,000 requests will automatically move to the next server. So that's what is about workload capacity balancing or workload balancing. I'll talk about other options, how this has been achieved in detail using load balancers and then using scalability. So they're the topics which are part of our plan, a part of my plan to showcase, and then that will also help you, because all these capabilities or all these foundation topics or pillars, right, work in conjunction. So high availability is achieved by certain tools. One of them is load balancer, and other one is scalability. If your system is highly scalable, then you are achieving high availability. They are separate terms, but they work in conjunction. As I was mentioning about scalability, so what is scalability? Very important term to understand. And from cloud perspective and from on-premise perspective, what differs? Okay, that's very important for us to understand. Scalability is a system's or organization's ability to handle increased demand, such as a rise in customers or workload without compromising performance or quality. So what I mean by that is, as I was giving example, that you are getting more number of requests than you. Let's say there's a peak time. Every system has their peak time, and so what happens is during that peak time, is your system is able to perform with a similar high, is your system still highly performant or not, with the and serving the request with high quality? So if yes, then your system is scalable, then your system is resilient. So scalability is a system or organization's ability to handle increased demand or a rise in number of customers. Means that if number of customers are more, the number of requests which you're getting to be served by the server, right, or application, will be high. And if your system is able to scale accordingly, then it's highly scalable system. There are two type of scaling, right? Horizontal scaling and vertical scaling. What is horizontal scaling? adding more machines or instances to a system to spread out the work. Means you are having, let's say, you have configured two servers, right? You have done your capacity planning and you have configured that this will be your CPU, this will be the RAM, and this will be the storage. And that way you configured both servers of the same capacities. But now you are getting more requests. That means you probably need more than two servers. So horizontal scaling is if you add one more server, extra server altogether, a new server altogether, that's called horizontal scaling. It can go from 2 to 5 to 10 to 100 depending upon requests, right? Depending upon the volume of the request and count of the request. How it works, the workload is how scalability works is, or horizontal scaling work is, the workload is split across multiple servers. So if one server fails, others can take over, improving fault tolerance, right? So again, we talked about it that if workload is, once you're having more than one server, the load will automatically get spread. How it is getting spread, I think there's a way to do it. We'll talk about that also. But in this case, we are having more than one server which is taking care of your request. What it is based for, handling large or unpredictable traffic volumes. This is very, very important term to understand. So let's say today is a Black Friday sale going on in UK right now. It's a time of Black Friday sales, right? So in this time, you probably can predict that probably every day you might be, or every time you might be getting these many number of requests per second, maybe 1,000 requests per second or whatever. However, there's a high possibility that your prediction goes wrong and you might get 10 times of volume, right? You predicted for probably 1,000 requests per second, but let's say you are getting 5,000 requests per second. Now, question is your system scalable enough? If yes, that means you have set that can be achieved only by horizontal scaling in real time, right? There is a way to do it in vertical scaling also. I'll talk about it, but it is not efficient way of doing it. Why? I'll explain it later. Okay, so adding more web servers, for example, as I was explaining, right? What is the example of horizontal scaling? Adding more web servers to a cluster to handle increased website traffic, right? So that's a very common example. Like say Amazon has sales, right? So whenever there's a sale day, you all know, right? How many requests are there? Definitely are much more, maybe 10 times or sometimes even 100 times more than a normal day's request, right? So that's the scenario wherein if your system is horizontally scalable, right, and on it can handle those unpredictable traffic immediately, right, that's when your system is highly scalable. Vertical scaling, so upgrading an existing machine with more powerful components like CPU, RAM, or storage is what vertical scaling is. That means you're having a single server, right? And you are enhancing its capability by increasing its CPU, its RAM, and its storage. So that is the challenge. If you want to handle unpredictable traffic, right? Probably what you can do is for this kind of scenario, like today is a Black Friday sale, or let's say this Black Friday sales is going to stay for 10 days, right? So probably you will add certain CPU, RAM, additional CPU, additional RAM, or and additional storage in your existing server. However, it's highly likely that uh, the request you are going to get, you have not predicted it, right? And these resources which you have added additionally are also not sufficient to handle those requests. So it's difficult to manage it in real time, right? You can still do it. And the other challenge with this is, what you do is you are actually buying those resources, right? Extra CPU, extra RAM, and extra storage. Now you have to put on the shelf tomorrow. Whereas the in cloud, right, you can you have heard it many a times, that pay as you go, right? It's one of the common terms used in cloud, right? You are paying as much as you use. So today you need it, you use it. Tomorrow you don't need it, you don't need use it, because you will be charged only for the resources you have used at that point in time or that given period of time, right? So that's the difference how it is happening in cloud. So a single machine's resources are boosted to handle more load and then based. Sorry. based for quick, moderate growth or resource-heavy applications where a single powerful machine is sufficient. So that's the one of the important. So what I'm trying to say here is it's better to use horizontal scaling, right? Especially if your system, if you know that the request can go up and down and all of it. There is a one common term which is used in vertical scaling is scale up and scale down. Whereas in horizontal scaling, we talk about scale out and scale in. Means you're having 5 servers today, you add all of a sudden your request is getting higher. You have configured that. Uh, there is a term called auto scaling. If you go deeper and touch upon those topics in AWS, then we'll talk about these terms in more detail. But there is something called auto scaling. It's scaling automatically. So if you just see and try to understand the term auto scaling, automatically scaling means that your servers are already configured in such a way that as per the requirement, if the load on the server increases by X% to Y%, the number of additional server you will get automatically added, and that those will handle all the additional requests. Similarly, if the request is getting down, then those servers will switch off. So they will be not serving any request anymore. And that's why you will be paying only for that particular set of servers when you need it. When you do not need it, you're not paying for it. Right. So that's the difference. Now, load balancer. I'm very, very sure you have heard these terms many a times, right? A load balancer is a device or software that distributes network or application traffic across a group of servers or prevent any single server from becoming overloaded, right? We were talking about it, right? How you achieve high availability, how the traffic is can be controlled, how the traffic can be distributed, right? So load balancer is that particular tool, right, which helps us to distribute the traffic across different servers, right? So that is I mean, if you see this is pretty clear. It's not always that you have your request from client will go via internet. It's also possible that all the request sits inside your uh, private cloud or private environment. It might not be just cloud, but in general, if it even in on-premise system, request might be coming to internet, or and then it is like if the site is an external facing site, right? Let's say Amazon.com. That's when this will happen. Uh, However, it's possible that we are also talking about the private network, but that's fine. That's not a part of discussion today, but just want to clarify that. So if you see this request is coming to load balancer from different number of people. So we are sitting here, right? We're sitting here, we're sitting here. That let's say there are hundreds of such clients here, right? Now there's a load balancer. How it works is it is distributing all this traffic which it is receiving from the client and distributing across these servers. Now in detail, I go and then explain you like how it works, load balancer, how load balancer works and all of it. So what it does is it accepts uh, load balancer receives incoming requests from users, acting as front end for the server pool, right? As we showed in the diagram here. So it is receiving the request from the client, right? And then it is a front end for the server pool because these are server pools. Before it hits the server, there is a load balancer here so that it can handle the requests. It uses algorithm to distribute requests, right? It uses a predefined algorithm to decide which backend server should handle each request, right? So there are multiple ways to have, or there are multiple algorithms using which this can be done. So I have put in two different types. One is static algorithm and one is dynamic one, right? So it distributes traffic based on predefined plans like a round robin, which sends requests to server in a sequential rotating order. This is not efficient. What I mean by that is this: if I'm using round robin, then it will send request number of let's say there are 50 requests. So 10 requests, first 10 requests will go here, the next 10 here, the next 10 here, the next 10 here. So that's the round robin works. But what I'm saying is this is not efficient. Why? I'll explain later. So dynamic algorithm solves that problem. Distribute traffic based on the current server load, such as least connections or server health to ensure efficiency. What I mean by that is, uh, if you are getting 10 requests here, 10 requests here, 10 requests here, and so on and so forth, it's possible that either this server is not, let's say this server is already loaded, or the request, specific request out of 10, let's say there are two requests which is taking too much of time. But because it is getting in sequential order, the 51st request, like we have already distributed 10, 10, 10, 10 here, right? The 51st request will again come here, even though this server is loaded. So this is the challenge with the round robin, right? It does not check the health of the server. It by default, sends the request in the round robin fashion, regardless of the status of the server. So that's the challenge with the round robin algorithm. So the better one is the dynamic algorithm, which checks the health of the server, and accordingly it sends the traffic. So if you see here, or that's what I have mentioned here, monitors server health. The load balancer continuously checks the health of the backend server and redirects traffic. If a server fails a health check, the load balancer stops sending traffic to it and redirects requests to the remaining healthy servers. So what I mean by that is, let's say this server is not responding to load balancer. So ideally, in a normal situation, this server should keep sending the health condition of its own to load balancer. The moment this load balancer is not receiving anything from this server, it stops sending traffic, because this load balancer is not sure whether this server is healthy or it is not. Then you are left with only three servers here. So that's how this load balancer works, which is good, right? Because if you see that this server is not working and still you keep on sending load, those load will not be processed, right? Your system will fail. Then these requests, those clients requests which are going to this server will all fail if the load balancer keep on sending requests even if this is not responding, right? So that's how the dynamic algorithm works. Add server back. Once the failed server becomes healthy again, the load balancer will add it back into the pool of available servers. Increased availability by distributing traffic and routing around failed servers. The load balancer ensures that the application remains available and performs consistently. We already talked about it, right? How much time we are having? Okay, so we are having close to 20 minutes. I hope you are all following along, and if you have any questions, as I mentioned earlier, you can put in the chat, and then we can take, if time permits, toward the end of the session. Yeah. Hello.
Sure, Pawan. We can add the questions in the chat, and if you have any questions, do let put on the comment. So Pawan will take the questions in the later last part.
Yeah. So we are having close to 20 minutes. I really doubt that we'll be able to cover. But let's say I'm not in a hurry. We might have one more session just for storage if needed. So we'll do that. Okay. So coming back to the foundation topics, domain name server, which is DNS. I'm very sure you would have heard of DNS of many a times. And recently there was an outage at one of the AWS region in USA, right? It was related to DNS, right? So of course, not going that deep, but DNS is very, very important, right? So what DNS is? What is the importance or significance of DNS? The domain name system is the phone book of internet. What does that mean, right? So humans like us, we access information online through domain names, whereas web browsers interact through internet protocol address, right? IP address. So DNS does that translation. The moment I'm putting www.google.com, right? The browser sorry, we understand that, but browser does not understand. So what browser is looking for? What is the IP address of this particular this particular name which I have put in the browser? So it is the DNS which translates that domain name into IP address. And once the browser receives that actual IP address, and all of this happens at the back end, right? Then only it connects to that particular resource which is sitting at that particular IP address and gives us back, let's say google.com or yahoo.com or amazon.com, right? So once the IP address has been retrieved by the browser, then only it gets the actual resource we are looking for on that particular server or that particular IP address. So there are four DNS servers involved in loading a web page. It's very important for us to understand, because many times this is a very common question in interviews, especially the tough interviews, I would say, in Amazon and all. This is quite common, but still you need to and because it's a common question, that's why you need to know it very very well. So these four servers, right? DNS recursor, root name server, TLD name server, and authoritative name server. These four servers are responsible to provide the actual IP address which is mapped for that particular domain name. Let's say example.com, google.com, right? So all these four servers are involved. I have put step by step how it works, right? So you enter a domain name, right? You type a URL such as www.example.com into your web browser. What happens next? Now, your browser or operating system first checks its local DNS cache to see if it has recently looked up at this domain name. You all know, right? All of our browser has its own cache memory, right? So it will see if I have. That's why once you clear the cache, you cannot retrieve. Like you put, it takes time to retrieve any data which you're frequently accessing till now, right? So it first check its local DNS cache, that have I recently retrieved this example.com. If yes, then great, then no issues. But if it does not, then it goes for the next step. So what the next step is, the query goes to a recursive resolver. If the IP address isn't in the cache, your computer sends a DNS query to a recursive DNS resolver, which is often provided by your internet service provider. Often, not always, but often. The resolver queries other servers. The recursive resolver checks its own cache. So even a recursive resolver, which is also known as recursive DNS resolver, they also check its own cache. And if it is not available in the respective cache, then it is the next step. And what is that next step? It starts process by sending queries to other server in the DNS hierarchy, beginning with the root DNS server. So from browser it goes to DNS resolver. From recursive resolver it goes to root DNS server, right? So this is the two step now. If root DNS server also does not have it, sorry, my bad. So what root DNS server does is, the root server directs the resolver to the correct top level domain. So this is very important for us to understand. So top level domain, TLD server, here it all depends what is the name we are putting in the browser. If it's example.com or example.org, right? Or example.net, right? So that becomes top level domain for us. So in this case, I have put example.com. So that's why I put .com server. However, it might be, if it is example.org, then it becomes .org server. Okay. So that becomes our top level domain. Okay. Sorry. So then the TLD server directs the resolver to the authoritative server, which is the final frontier, which is the last step, right? And for that specific domain, like the whole domain, example.com, right? So the IP address is then returned by the authoritative server. So it is the responsibility, the eventual responsibility of authoritative server, right? If none of these first three layers are able to get this done, then it comes to authoritative server, and then they respond with the actual IP address. Now the IP address is returned. The authoritative name server holds the official record and sends the IP address back to the recursive resolver. And recursive resolver, which is the first step here, if you see, right, this is where it returns back to your browser, and your browser then connects to that server on that IP address. Let's say 192.116.12.10, right? Is the IP address returned. So it connects to that server where the google.com or example.com resources are sitting, and then it renders in front of you in the browser. So this is the end-to-end step how DNS works. Very, very important for all of us to know this. Next one, content delivery network, CDN. How many of you have heard of CDN? Have you heard of CDN, content delivery network?
Yes.
Okay. Uh, because If you want to say what is content delivery network, it's fine with me. Otherwise, I'll go ahead.
Content delivery network is a network which provides access to the edge locations. It acts
Wonderful.
as a
Yeah,
edge
that's
location, and the
yeah,
nearest region infrastructure resources can access content delivery. It is based on the
absolutely you're
concept
right.
of edge location. It's
Yes, it's based on the edge location, which is nearest location for the given user, right? So I'll talk in detail. A content delivery network is a geographically distributed group of servers that catches content close to end users, right? Uh, how many of you have watched Netflix series or Amazon web series, Family Man or Mirzapur, right? Most of us, right? Some or other, I'm not talking about that specific series, but most of us are watching Amazon Prime or Netflix very regularly, right? Or at least sometime. So all these organizations are using for this particular streaming services. They are using CDN big time, right? Like Netflix has its own content delivery network. They are not using any third party network. They are having their own provider. It is their own. Whereas Amazon, as we all know, there is something called CloudFront and Cloudflare, Akamai. They are very top level of CDN provider. So let's try to understand how it works. As I mentioned, today the majority of web traffic is served through CDNs, including traffic from major sites like Facebook, Netflix, and Amazon. A properly configured CDN may also help protect websites against some common malicious attacks, such as distributed denial of service (DDoS) attack. Right? You must have heard of this attack, right? So this also helps in that. Example of CDN, as I mentioned, Cloudflare, Akamai, Amazon, CloudFront. Now, um how CDN works. Try to understand. It's very simple, not very complicated, right? So there is a concept of two servers here: origin server and edge servers, right? So origin server is the CDN's man server, where the actual content is sitting, which hosts the website's original content. What is the edge server then? Servers located in data centers around the world that store a cached copy of the website's content or static content like images, videos, or CSS file. And how it works. So let me give you an example. So when a user requests a website, the CDN's DNS system identify the user's location, right? And the user, okay, before I go to this step, let me explain you. Let's say I requested for a content. That means I'm clicking on Amazon Prime, right? I was already watching Family Man, right? That means that particular content is already sitting in the location which is near to me, right? It might be somewhere in Europe, quite maybe in London, for example, right? So it is easier for the edge server there, which is probably in London, let's say, just example. I don't know what the edge server they have for CDN in my case, but just it could be just hypothetical, but that's how it works. They already have that content that I was watching Family Man. Now it will be easy for them, probably very quick for them to respond with that content. However, when the next Family Man series coming, right? It might be coming somewhere in the end of this month. Whoever is the first person in that specific geography, let's say Europe, right? For that person probably, because it's the first time the content is getting loaded, right? And that particular user has never requested for it, right? So the first time when it goes and check the edge server, it might not find that content there because it is not getting loaded and cached, right? Then it goes and check the origin server, but that's the only first time, because from UK there must be probably hundreds and thousands of users who will be watching it. Next time onwards, whenever a person is watching a Family Man, right, they will probably take milliseconds or even lesser than that. So and that time it will not look for origin server, it will look for the edge server. So what it does is, once it does not find the specific content in edge server, then only it goes to origin server, and that's how it saves a lot of time. It saves latency, and that's why user feels good about the content which is at the disposal immediately. So this is how it works. The DNS routing and all of it is a technical term, but you can understand the user is automatically routed to the edge server geographically closest to them, which is, I explained that if I'm in London and there is a server, I'll be routed to that server. If content is not found, then it will go to the origin server. This is how it works. Content delivery, the edge server delivers the cached content to the user, resulting in faster load times and a better user experience, right? So that's how CDN works. Firewall. A firewall is the first line of defense that monitors incoming and outgoing traffic and decides to allow or block specific traffic based on a defined set of security rules. I'm sure firewall is again very common term. You must have heard of it many a times. So firewall rules are precise directive that form a critical for part of firewall configurations. They define the conditions under which traffic is permitted or blocked based on parameters such as source and destination IP address, ports, and communication protocols, and all of it. So see, there are number of firewalls which AWS has, especially to secure your VPC and your VPC artifacts. Like, for example, you're having security group, right? Once probably next session or next to next session, when I talk about VPC, and I will definitely talk about security group and how you create a security group to secure your virtual machine, which you have created in your VPC, right? So in the context of firewall rules, firewall rule, what I'm trying to say here is when you create that rule to secure your virtual machine, you are taking uh, into account uh, number of things. One of that is IP address. The second one is port number, right? And the source from where that request is coming. It could be you're going to identify the source through IP address, um, or maybe some other mechanism. But these are the factors, or these are the um, I would say parameters using which you are defining your firewall rule. In general, also firewall rules, as I mentioned here, if you see here, right? So it works on these parameters: source and destination IP address, ports, and a communication protocol. Sorry, protocol is something which I missed to mention. So whether it is along TCP, SM, let's say a simple message SMTP, for example, simple message transfer protocol for pinging and all of it. So depending upon what particular IP address you want to allow or deny, depending upon what is the how this particular firewall works. Like for example, security group, in security group, there's no deny rule; it's always allow rule, right? So in the conjunction of your port number and your protocol, you can define your security group and source, of course. So with the source name, from the and destination name, of course, destination in this case, if I'm using security group, will be your EC2 instance. Again, let's not go into security group because that's going to be a separate discussion altogether. That's just example I was giving. So you going to use IP address, port number, and the source and destination name and IP address, and that's how you define the firewall rule. So I think I have mentioned a lot of things. I'm not sure whether I should mention because I should go in this level of detail because we are left with very less time. Uh, so I'm not sure how to go about it. We have not even reached storage. So okay, maybe
Pawan,
how you
you
want
can
to.
take you can take the storage as well if you have a time. Otherwise, we can carry forward to that carry forward the
Yeah,
timings in the
storage will
next
take
session.
at least 45 minutes. The kind of kind of content I have created for storage. So, and we are not even done with this. After firewall, we have okay. Firewall is probably the last topic. So let me complete firewall. Okay, and we are towards the reaching 3 p.m. So I think you don't need to do extension of this session, or you have already done it, Abby.
Yeah, sure, Pawan. Yeah.
Okay, let me go ahead and spend probably 10 minutes more and see how much I can cover. Okay.
Yeah, okay, Pawan.
Yeah.
You can continue with your session.
Yeah. Uh, So I was mentioning about firewall rule. So you are taking into account a number of factors or number of parameters, starting from protocol to port number and source and destination IP address, using which you are defining firewall rule. That's very important for us to do that. I have used certain types of firewall, and also there are certain terms which I mentioned, right? It's a combination of firewall type as well as some of the important terms about firewall, which is going to help us to understand what is the how specific firewall works and how you configure a specific firewall. Like first of all is packet filtering. Network security technique, which is packet filtering, is it is used in firewall to control data flow between networks. It evaluates the headers of incoming and outgoing traffic against a set of predefined rules and then decides whether to allow or block them, right? It's very common, right? So in most of the firewall rule, either you do allow or you do deny or you do both. So that's how every firewall works, but every firewall is different, and we should understand what is the difference between a firewall 1 versus firewall 2. That's what I'm trying to explain here. So stateful inspection, as name suggests, right? Stateful packet inspection analyzes the content of data packet and compares them to the information about packets that have already traversed the firewall. What it is saying that it is, let's say there's a request coming to firewall, right? Because it's stateful, it has the record of every other request which has entered into that particular area. So that's why it is stateful. So it has the tracking of each and every request, and so whenever that particular request comes next time, it can do the complete tracking starting from now till, let's say, any given point in time. So that's the meaning of inspection. Web application firewall, this is very important for us, right? Web application firewall, WAF. Amazon has its own WAF. It wraps around a specific application and examines the HTTP request being sent to it. Similar to other types of firewall, it then applies predefined rules to detect and block malicious traffic. So let me not go into this detail. What I'm saying is, uh, WAF is securing your application. It's an application layer firewall, right? So that's how it is. There are cloud agnostic firewall or with third party firewalls. AWS has its own web firewall, and there are third party firewall which is provided by other providers like Checkpoint, Cisco, and many other providers provide the firewall. I'm not sure. I'm not able to move. Sorry. So next is high availability firewalls and hyperscale resilient load sharing clusters. Uh, Virtual firewall, next generation firewall. So I'll not talk about all of it. Let me talk about next generation firewall because it is very important. Nowadays, most of the organizations are uh, using, or it's a best practice to use next gen firewall. Why? Let me explain. So next generation firewall focus on blocking malware and application layer attacks, both. Okay, along with an integrated IPS intrusion prevention system. These next generation firewalls are able to react quickly and seamlessly to detect and combat attacks across the whole network. So it has both intrusion detection system and intrusion prevention system. So both is integrated or embedded in the same firewall, right? Firewalls can act on previously set policies to better protect your network and can carry out quick assessments to detect invasive or suspicious activity such as malware and shut it down. So as I mentioned, there are service providers like Checkpoint, Cisco, and there are so many other service providers um, who are having top quality next gen firewalls. So it's advised that we all use next gen firewalls to secure our network as well as application layers. Somehow I'm not able to move my screen. I'm not able to go to my next page. Sorry. Yeah, it is moving now. Okay. So what I'll do is, Abby, I will just cover these terms and then I will say end for today's session because I have to cover a lot. At least how much I have covered so far, that much I have to cover further. So I'm very sure it's difficult to complete today. So I'm planning to complete this part, right, which is very important from terminology perspective. And then in the next session will be a continuation of stories dedicated for the stories. Is that fine?
Yeah, that's fine, Pawan.
Okay. So, for the storage, we have to understand these terms, which are very important term. And one thing which I want to mention to you, to tomorrow, let's say you are planning for AWS Solutions Architect Associate Certification. These terms like IOPS, throughput, none of these certification content created, right? Maybe some of them, at least I have what content I have gone through, right? Not just these terms, there are so many other terms they use in their codes, right? They have not been explained. So what you have to do is you have to go and spend your extra time, your extra effort, and try to understand these terms. Otherwise, what will happen is, for example, if when I'm going to talk about the storage, there are six types of AWS block storage volume types, and for each different volume type there are different IOPS, throughput, size, uh, and if you just try to mug it up tomorrow, you will not be able to make decision based on your knowledge. Why? You have just mugged it up, you did not understand. That's why it's important to you understand, so that when you work as an engineer or an architect and you have to choose, okay, for this particular EC2 instance, which volume is suitable, because if you're going to use that EC2 instance to host your big data, maybe RDBMS like MySQL Server, for example, right? So depending upon usage, or you're just going to install your or host your application server, which is just serving probably 100 requests. That means you need to ensure that you're not selling your client a very costly software, right, even though it is not required. Whereas you are, if you're not sure which server or which particular volume type to use for big data, right, you might be creating a EC2 instance with a volume type which is non-performant, right? So it's important that we understand this terminology, and we should just not focus on certification, rather we should focus on learning. Okay, that's the reason I specifically put down these points. I spend my own time and try to how I can explain these terms. So IOPS is a very very simple term. It stands for input output operations, right? What is the meaning of IOPS? And IOPS says how many actual read or write operations a storage device can perform in a single second. So that's the IOPS. Okay, throughput. Throughput is the measurement of how much data can be transferred, read, or written in a given amount of time. For storage solutions, it's typically a measure in bytes per second. Very simple definition, right? A higher throughput means better performance, as in faster data transfers. In comparison to IOPS, throughput tells us a specific amount of data that can be read or written in a given amount of time. This metric can be used directly or to understand if a storage solution is fast enough. It will not tell us if you can sustain a certain pattern of read or write operations though. So you understand now, right? Read and write operations in a single second, and this is how much the amount of data, right, in a given time is what throughput is. How to calculate throughput? To calculate the throughput without measuring it, we take the amount of IOPS, read and write, and multiply it by configured block size. Throughput equals to read plus, as I mentioned, right? Read IOPS plus write IOPS into block size. So again, this is in the context of block storage. That's why I'll talk about the block storage. That's why I'm taking these terms earlier than starting before starting the block storage. Since IOPS and throughput are related to each other, that means to give a full picture of storage performance, both values are required. Okay. Here is an example here. So throughput gives us a feeling of how much actual data we can read or write in a given amount of time. If we know that we have to write a 1 GB file in less than 10 seconds, we know that what right throughput is required. This is just an example, right? If you understand this, then it will be easy for you to calculate this, and accordingly you can choose a specific volume type once you're going to use AWS block storage volume type. Of course, I'll talk in detail about it. So let's say, for example, these topics I have put in, but there is no time today to compare and then uh, discuss about it today. So with that, I'm done with today's session. There is a lot to cover. If you see my screen, I have lot of things I have put in the content, but today I can't. My God, I can't take all of it, so I have to stop the session just right here.
Yeah,
Okay,
thank you so much
so
for delivering the session on. You have covered most of the fundamentals like storage, compute, scale horizontal and vertical scaling, and availability and DR, load balancing in DNS as well, and also the introduction about the throughput and things. So, if you guys have any questions on the session, you can have 5 minutes and have the session. You can unmute and ask the questions.
yeah, please.
You can raise the hand and go by one.
If not, then what you can do is if you're looking for any, yeah, Amisa, yeah, please go ahead.
Good evening. So, good evening, everyone. It was a very insightful session, and it was a refresher for me because I was quite well versed with certain concepts, and I'm looking forward to finishing this certification in a couple of months. I wanted to know what could be the resources I can use to prepare for this associate solution architect certification.
I have gone through. Thank you for your question, Amisa. I'm
Yes.
sure this is a very common question which can be relatable for many of the resources. So I have gone through Stephen Marik's course for AWS Solutions Architect Associate, his Udemy course, and I have also used Tutorial Dojo's practice set papers, which is very good quality. It Because the question sets we are going to get in the exam and the patterns which Tutorial Dojo provides, it matches a lot. So it's very good practice for us. However, that was not the only resource which I have
Okay.
used. I was part of a community called BESA, Become Solution Architect, which is created by a number of Amazon resources, Amazon employees, and I have been part of that for a while. They have very wonderful cover for most of the topics in quite detailed way, right? So that was because I was part of it, so I was going through those also for specific topics, whether it's a VPC, whether it's a networking or encryption, and so on and so forth. So these two are the resources I will suggest. While practice paper, there is a tutorial dojo, and Udemy course, I will suggest again Stefan Malik.
Stephen Malik.
But additionally, if you go and in YouTube video, you can find out. I can share those links also later on about
Sure. That
beta
would be
sessions.
helpful. So,
Yeah, so
but
where
what
you
is the
can.
time length and the duration which one should spend if we should?
That's a very. I mean that depends. Like I gave myself 6 months because I did this 3.5 years back. In fact, my recertification is coming. I need to recertify myself. So at that time, I was, I mean, that was my first attempt. So I took quite a while. So it might take probably 3 months for somebody who's already working a lot, but somebody who is not working as much, for them, they should give enough time. So it might go from 3 to 6 months. It all depends on how much you're already working on AWS.
Sure. So that's really helpful. Are there any hands-on questions too that the
Yeah, some of them, not many, but some of them, especially networking and then security, like they will ask about the policy and all that. So it's like if you've done the hands-on, it will be very easy. Networking is something I have done a lot of hands-on because I come from development background, but because of so much of hands-on, I got a lot of confidence.
Okay. Thank you. Thank you so much.
Yeah. Any other question? Yeah, Jayanti.
Hi, I am very relatively new to cloud. I am learning cloud, but I'm actually a database person. So, is it necessary that I need to do the fundamental certification and then go for the solution architect, or I can directly go to solution architect? This certification, associate certification.
Again, it depends on you. However, as you're already working in database, so probably my understanding is you're already knowing the fundamentals. So you might target for AWS Solutions Architect Associate. If you are not working on AWS at all, then probably you would have gone for practitioner. But again, it's your decision. You can still go for practitioner first and then target Solution Architect Associate. Practitioner probably you can clear in one month or maybe 5 weeks. Yeah, that's very easy.
Okay, thank you.
Yeah, I think yeah we are done with the questions time. We are done from time perspective for our questions. So yeah, Abby, you are mentioning something about quiz.
Yes, Pawan. So this we are having a quiz here now. So Nandini, please share your screen and we can have the quiz. So it's based on what you have learned today. So it will be the questions will be it's 4 to 5 questions will be there, and you can join the Slido. And over to you, Nandini. You can take it.
Yeah, Abhi. So just Canvas. So we will be, having like around 5 questions based on this session. So we can have it in four.
Meanwhile, everyone, I have shared the feedback form. So we have planned to give the certificates to who has joined and completed this session. So the session one certificate each go by that way. So I have shared the feedback form. Whomever filled the form, or we will circulate the certificates in upcoming weeks. And you are welcome to write a blog on today's session and tag us. So we will feature that on the AWS Women in Tech. And I also shared a Women in Tech WhatsApp channel over in the chat. So you can join the channel for further updates and events and resources on AWS.
Yeah. So Abby, if you are fine, can I? Well, I'm at my hard stop now. So
Yeah,
can I drop off? I need to go somewhere.
yeah, sure, Pavan. If you have like other plans, you can drop off. And thank you so much for joining and enlightening us with the fundamentals, Pavan. Yeah, looking forward to the next series.
Yeah, so again, as I mentioned, the people who have joined this, I'll request if you really like this session, I would invite you for the next session as well. Uh, the plan was to go for the VPC session in the next call. However, the way it has panned out, we are only halfway in this session, so we could not complete the planned number of topics to cover, especially the storage deep dive, which we are going to cover in the next session. So please join us in that one. Abby, Rasika, Nandri, thank you so much. And these are the people who will give you of all the details and keep you updated on that. Okay, with that, talk to you next month. Okay, thank you.
Yeah, thank you so much, Pavan. Yeah, bye bye.
Thank you.
And Nandini, you can start the quiz. I think people are saying it's you can't see the question.
Yes, Abhi.
You can start the quiz. Yeah.
So now the question is visible.
Can everyone able to see the questions?
No,
No,
no.
Uh, Nandini, can you start the quiz? Go ahead
Yeah,
and start the quiz.
yeah.
Can you able to see the questions, guys? Anyone unmute and say?
Yeah, yeah, it is actually visible.
Akka, just one question.
Uh, are you not able to see like an expression?
No, no,
Yeah.
no. I just got one.
Oh, mm,
Can you swipe to the next question, Nandini?
yeah, I actually swiped it.
No, like for me, it just went out.
Okay, I guess I was having like a duplicate the one another board, which is actually having a one question. Mm. So now, are you able to see the second
Ah,
question? Yeah, thanks for the confirmation.
Everyone encouraged to join the quiz and have.
So most of them look like answering all the correct answers only. I guess we are given like more straightforward questions. So everyone getting good answers.
Yeah. Glad to have all of you in the session, and I'm happy to see the count till the end of the session. Actually,
So it is will be like our last quiz question. So we have Divya and Amsha and Vishal has been like a top. Vishal, Didi, Wo.
yeah, you can
Is
share
all
that with dashboard, Nandini, and
okay,
share the
okay.
dashboard.
Yeah, sure.
Yeah, Congratulations, Divya, for winning the quiz. And everyone got 4 out of 4, but Divya wins like in the time seconds, right? So,
Yes.
yeah. Thank you each and everyone for joining the session today, and glad to have you all in the series. And if you want to get the updates from the next upcoming sessions are lined up, I have shared that those dates in the chat